Hi, this is an overview of small industrial RO plants we supply here at FilterShop. Basically, RO you'd use when you want to dramatically reduce the mineral content in water, whether it's a borehole which is a horribly high mineral content, or if it's simply a case where you're needing very low mineral content water, or just looking to improve the taste of a mediocre water. What we're running through today here is the 2 membrane plant, but 1, 2, 3 and 4 membrane plants are basically identical. They just have extra membranes on, so the same concept applies to everything. Okay, firstly let's start with the electrical side of the unit and how it works and what you actually need to connect. First, we open up the panel with the included key. And at the bottom here we have a guide to show you what connection pins are used for what different things. Firstly, we have our power in with a guide there. There's a spare grommet for the power as well. It's simply connected to this connector. Then the next one is a feed pump, which you would connect here. This is if you, for example, have a fairly large pre-filtration system or you're drawing from a tank. You can link the feed pump directly to the system, so you can control it from this control panel, and that it doesn't need its own system to control. Here's this power out to the high pressure pump. Then we've got, for the 2 valves, there's 2 solenoid valves on the inlet and to flush the membrane. Then next here we've got the feed water tank and the pure water tank. Now these are both optional, and basically what you would do for them is you want to get these kind of level floats. Basically the concept with these level floats is when they're hanging down, that it's got a little ball in. So what it does is if it's level, it's not connected to anything. When it drops down, it's got a ball that connects 2 of these 3 wires together. And then when the tank is full, the ball rolls back and connects 2 different wires together. Now the easiest way to figure out what to connect to what is on here. The central point is the common wire. So just take a multimeter and measure if it's down, which one is connected, and then if it's up, which one is connected. One of the wires will be in common, and that's the one you put in the middle. If we have a look in the system here, let's say if we look at the product water tank, your HH would be high level high, so that would be the one that's triggering when the float is at the top, which would be connected to 211. The common wire will be connected to the center one, which is the D+, and then your high level low for when you want the system to switch on again would be connected to 212 there. There's a pre-treatment lockout functionality in this as well. This isn't something we commonly use, but you get some automatic filter units which, when they're busy regenerating or flushing, can actually give you a signal out to a different unit to turn off. So for example, if you have a softener that's compatible with that, the softener will not allow the RO plant to start when it's busy running its regeneration cycle. The rest of this, the only thing you really need to know about is there's 2 switches here. Turn both of them on. The pump gets started up in phases, so you don't get the full power of the pump immediately, and that's just to protect the piping, so you don't have a massive pressure spike when the high pressure pump starts. This extends the life of the pump, and of course helps that you don't by accident burst any pipes or anything like that. And yeah, that's basically the inside of the electrics. Okay, next let's run through the control panel. The pressure gauges and the flow meters we'll get to later, but just your basic control panel here. Here's a conductivity meter to give you a baseline of what the current product water's conductivity is, and conductivity is very closely related to mineral content, so that you would use as a baseline to set up the system. Then you've got a few different alerts. You've got a feed tank level low. That means if the system stops, it'll tell you here why it stopped. If you've connected up the level flow to the feed tank, it'll tell you, okay, hold on, there's a problem with the water in the feed tank. If the pure water tank is full, that will also bring up a warning here. And then here we've got pressure warnings for the RO, a low pressure, overpressure, and then if the pre-treatment is blocking the system from turning on. And then vice versa, we have at the bottom here, we have one to tell you that the feed pump is running. Each of these has a switch linked to them, which you can either manually turn off the feed pump, manually turn it on, or leave it in automatic mode where the system actually controls the pump when it's switched on. Typically the automatic mode would be fine if the feed pump is only powering the system, but if you're, for example, teeing off before the RO plant and using the higher mineral content water that's already filtered for something else, you can then manually switch on and off the pump here. The inlet valve is just the solenoid valve to the system that you would normally leave in automatic mode. The high pressure pump you would also normally leave in automatic mode, that it manages itself. The flush valve, however, is one which you might want to run manually if you're using a high mineral content water. The idea behind this is, if it's on automatic, is that the system automatically flushes the membranes when the mineral content starts to climb of the product water. Now, if you're using this system on extremely high mineral content water, you might find that the system keeps trying to flush itself because it's not happy with the amount of mineral content coming out after the membranes. So if that's the situation, you will just have to do this process manually. What this also allows you is, if you're busy with doing something different, like just want to flush membranes and you don't want to start the high pressure pump, you can manually open the inlet valve, you can manually open the feed pump, and then leave the high pressure pump off and open the flush valve. Then in effect your feed pump's pressure will be allowed through right to the membrane, and you'll actually be using your feed pump to flush the membranes instead of starting the high pressure pump, which might be completely unnecessary. Basically what this does, it gives you options, and it gives you options for troubleshooting as well. Basically, when you want to install the RO membranes, there's really one big thing to remember, and that is to have a look on the actual membrane which side has a seal on it. Like this side doesn't, the other side here does. Now normally the seal is pointed towards the end. It basically forms a V that stops the water coming from here. Occasionally you find that the seal is put on the wrong way around, then you can just swap it, or just use the same basic concept that we're going to explain now. The membrane housings actually has a direction of flow on them, and that's basically how to tell you which direction to install the membrane. You want the tall part of the V of the seal to basically be blocking the water from coming through past the membrane and forcing it to go inside. So in this case we'd want to install the membrane like this, with the seal on the bottom, and in that case we'd want to install it with the seal at the top. What's a good idea on the seals is just very little bit. If you just put a little bit of Vaseline on your fingers, just rub it around there just to allow it to slide in, and then you have a look at the top caps here. Same concept. You have two Allen keys which you open it with. This is just the plug for the other side of the product water for the membrane. This system draws it from the bottom, so this serves just to block it off. So unscrew these, take it out, take out this end cap, put a little bit of Vaseline on those seals as well, but really just a tiny little bit, and then you insert the membrane, push this back in. The reason why we use a little bit of Vaseline there is this these end caps can be quite tricky to push in. Sometimes you even require a rubber mallet to lightly tap it to go deep enough so you can refit the retaining brackets. But yes, that's basically what it takes to install the membrane. Other filters that needs to be installed, we've got a single big blue housing on here. It's really just as a safety net. So it comes with a sediment filter. You should already have filtered before it, but the idea basically is, if you leave it too late to change the filters or forget to change the filters, this is just a safety barrier to prevent dirt from actually getting onto the membrane. Alright, let's have a look at how the water actually would flow through a system like this. First thing, you'd connect your water in here to the side of the big blue housing. Then from there it actually goes down into the high pressure pump, and we go out out of the high pressure pump, and this is a throttle valve for the high pressure pump. And basically when you would want to change this is if you're getting that the system's tripping out on high pressure almost immediately when it starts, then that means this valve is too far open, so we're getting too much water through, the pressure climbs and it trips the switch. This we'll talk about a little bit later, but this is for CIP. And then the water enters the membrane. In the membranes it basically splits. Basically what RO does is you have a filter surface, and you have water with minerals going across it, and it's constantly trying to form crystals, so you always have to have water flushing it to keep those crystals dissolved. And that flush water, in this system you can do one of two things with. Normally you can only do one, and then you have the product water going through the membrane. So if we look at the bottom here, we again have a CIP connection, which for most people would not be something they connect. And here we have the wastewater channel for the membrane. Now what makes this system a little complicated is it's got quite a few options on what to do with the wastewater. You can send it through here. This is your normal adjust valve, which is your flow to drain, which typically this is the only one you would normally have on an RO. Here we've got a solenoid flush, which you can control on the front panel, or the system can control itself, and this is to flush a lot of water to drain to clean the membranes. And this is an interesting one. This has got a separate flow meter, and this actually takes the wastewater back to before the high pressure pump. So where you would use this one is only if you have a fairly low mineral content water and you're trying to get a very efficient RO process, in that you don't want a lot of wastewater compared to your product water. Then you can actually recirculate some of the water back into the pump. Always, if you're using this, always keep some water going to drain, as if you just have a closed loop, you're just going to increase the mineral content, and you're going to write off the membranes. But typically what you could do is, say if you have a source water of about 300 TDS only, you can actually put some water back in here and just monitor the mineral content of the water coming out, and that does give you quite a bit of extra efficiency on the system. And then here is your actual drain connections. You'll see all the connections are actually labeled, but so the main ones are your source water, your drain water, and then the product water, which is connected back here. And that's basically all the water connections that you would normally have to do on the RO system. Okay. This system comes with functionality to clean in place, or CIP. And what this is it's basically, if you don't want to send your membranes in to get reconditioned, you can actually do it yourself. It is a little tricky and it does take a bit of time, but basically the only extra components you need is a separate pump and a separate little tank. What you would want to clean is, for example, if you have bacteria contamination or biological contamination, you would use a biocide flush across the membrane. If you just have salt content building up on the membrane, you could use low mineral content water to dissolve it. Or if you have scaling from hardness build up on the membrane, you can use an anti-scalant to flush through the membrane. In effect, what you do is you close off the entire system to the normal functioning units, and you bypass everything and put water into the membrane and take it out of the product and out of the drain water straight back into a different tank. How you'd connect that to the system is, this is your source water side, so we'd close off the valve completely coming from the high pressure pump, and then you'd open the CIP valve, and your small pump would pump into here, into the membranes, and then on the product water side, here you've got a valve to get the product water for the CIP, and again you'd close off this valve, which goes to your normal flow meter and product water, and open this one, and then on the other side we've got the wastewater side. So you'd open this valve, you'd manually close the solenoid, and you would close the recycling valve and the wastewater valve, both. Then in effect you've got a completely closed loop system, and you can just circulate the same liquid through and through with the extra pump, and that's how you clean the membranes. What's very important is empty it, flush it very thoroughly with clean water again. Okay, if it's with just the low mineral content flush, then it's not important, but if it's anti-scalant or biocide, you really don't want to drink that. So before you connect it up to run to your normal water supply, make sure you've flushed it thoroughly. Alright, So now let's actually run through the actual operation of the system and explain a little bit about what's going on in the rest here. For your main operation, basically you want to have all these switches set to automatic, except as I mentioned earlier, if you have a very high mineral content water, you might want to set the flush valve off, so you just flush it manually, as it probably will start to flush itself. So for normal operation, everything auto. Then then we need to look at the rest of the setup. You basically want to use these 3 pressure gauges, these 3 flow meters, and primarily this valve to set your normal running. So if you're starting for the first time, you want to make sure that this valve is quite a bit open, because you want to start off with most of your flow going to drain. Then you switch all your switches from off over to auto. You need to remember to switch the main switches on the inside there. Then what you should get is you'll hear the pump start up. You'll see your pressure on the high pressure pump side rise as the high pressure pump starts, and the source water one will rise when the feed pump starts, and then you'll get most of it running to drain. Initially, when the system starts, it'll probably start with a flush, so it will probably do a flush first. Please make sure to remember to flush the membranes as well, and just make sure that you have no preservative left on them before you start using it for normal operation. But let's jump ahead to how you'd actually optimize it for normal operation. So if it's a relatively low mineral content water you're dealing with, say 300 ppm or less, what you would want to do is you'd want to have about 2 parts product water to 1 part wastewater. This is product water, this is wastewater, this is recirculating water. So you'd want to set it to there, and then have a look at your conductivity meter and make sure it stays consistent. If the conductivity is staying nice and smooth there and it's at a relatively low rate, then you can start closing the drain valve more to increase the amount of product water to wastewater. So your drain water will go down, your product water will go up. Keep an eye on the conductivity meter to make sure that it doesn't start climbing. If it starts climbing, then you've taken it too far, and then it needs to flush more, because then you're getting mineral buildup on the membrane itself. Something else to watch here is as you're setting it, that your pressure isn't getting too high. You check them there, but here at the bottom we've got the high pressure switch. It turns off the system if you reach 12 bar. So you want to keep it under 12 bar, and this low pressure switch won't allow you to start the system if you have less than 1 bar in. So let's start with the low pressure. Here's your feed pressure coming in from your pre-filters. So if it drops under 1 bar, it won't allow the system to start. And it might be that you forgot to turn on the feed pump, or that when you turn on the feed pump, that it just takes a little while for the water to actually reach the system and build up pressure. Once it does reach it and build up pressure, it should start the high pressure pump automatically. Ideally, you'd want between 3 and 5 bar incoming pressure. The big thing to check with this incoming pressure though is what happens to it when the RO itself's pump starts. Because these high pressure pumps draw a lot of water. They can easily suck a vacuum, and then you find that it drops too low and the whole system kicks off, and you'll find that you'll get a low pressure warning here and the system will stop. The easiest way to correct it is actually to throttle the RO itself. This adjustable valve here throttles the amount of water going through the membranes. You would start off with it completely open and never completely close it, because then these pumps can deliver, I think, up to 23 bar, and you most likely end up bursting some pipes if you just completely close it. So, but if you find that you're dropping out on low pressure, you can throttle it down with this valve a little bit, so you have a little bit less flow going into the membranes. Then on your actual RO inlet pressure, that you'd also control with that valve. If you're finding you're triggering the high pressure switch the whole time, it could be that your drain is too closed, and that you're not physically getting enough water through the system. Or B, it could be that you're sending too much water to the membranes and you need to throttle it down a little bit for the pressure to drop. The drain pressure shouldn't normally be an issue at all. It should normally be lower than your incoming pressure, but if you find that this is rising to be the same as your incoming pressure, it probably means that something is getting clogged up there a bit, and maybe try running it at a little bit higher waste ratio, just so you have a slight pressure drop. The larger the pressure differential is over the membrane, the more water you actually get through. Okay, so now there's a third one here, which that is the recirculation. Now, if you have a high mineral content water, stay away from it, don't use it. If you have a low mineral content water, that's the second adjustable valve you have here, which basically just goes through that flow meter and back into before the RO pump. So if you're running on something like Gauteng municipal water, which is typically about 120 ppm, it's at low enough mineral content that the RO won't mind if you send some of the water back through it. What I would you adjust it with this one, but what I would recommend is start off with not more than 10% of the total flow going back into recirculation, and then have a look what it does to your conductivity. Whenever you get a situation that your conductivity is constantly climbing, that means you're building up scale on the membranes, and that's not good. So whenever it's constantly climbing over a period of an hour or so, it means you need more wastewater. If you're running recirculation, it means close the recirculation rather than just go to drain. If you're just running normally, it means you have to increase the amount of wastewater compared to product water because you're busy clogging up the membranes. So in effect, this one is your main friend to keep track of. Have you set it correctly? If it climbs, as I said, more wastewater. If it stays consistent and you're at a nice ratio, that's perfect. Keep an eye on it. If it starts to climb over time, then first step would be to do a manual flush for an extended period of time. If it's after a few months or a few years, it could be that the physical membranes just can't handle it anymore. Then you could either do a CIP to clean the membranes in place, or send them in to have them reconditioned. And then you normally get a decent bit of the capacity back on the membranes. If this one is, however, constantly lowering, that means that you're probably wasting too much water. At startup, it'll start to drop, but then after about 5 minutes, it should settle down. But if it keeps dropping over time, you could probably set your wastewater to waste a little bit less and increase the efficiency of the system. If you find that the level you are here is not a mineral content that you're happy with, and you want to actually create a lower mineral content water, you'd basically follow the same basic step, but what you would do is you definitely wouldn't use any recirculation, and then you'd actually allow the RO to run a higher wastewater to product water ratio. Like for example, with our larger version in our factory, we can actually create battery water and that with the RO, but what we then do is where we normally run at about a 80% product water to 20% wastewater. If we want to do extremely low mineral content water, we actually swap it around to about 70% wastewater, 30% product water, but then you're getting a very, very low mineral content coming through. Wouldn't recommend running it permanently like that, as it's a big waste of water and of energy. Remember, all the water you pump through here needs to be taken up to high pressure with that high pressure pump, and that does draw quite a bit of power. But yes, that's the basics of the unit and the basics of operation. Let's have a look at each of these error lights or running lights next. If we look at the error lights, the first one here is feed tank level low. That is, if you have a level switch in your water supply tank, it will turn on when the level switch tells the system that tank is empty. Same thing with the pure water tank, that will switch off the system if your product water tank is full. You can connect it up to that level switch. Some people connect it up to a pressure switch as well, and use it with a pressure, if you have a pressurized buffer tank system. The low pressure pressure on the RO warning would be here if you have your incoming water drops to 1 bar, and that is set here at this flow meter. As I mentioned earlier, if you're getting that, first check that your pre-filters are nice and clean. If your pre-filter setup is correct, check that that throttle valve on the high pressure pump isn't maybe open too much. Then RO overpressure, again you can control it with the flow there, and something that is something that you can bypass with the pressure switch, but we really wouldn't recommend it because the system was designed to run at 12 bar. Some people run the RO systems at higher pressures like 20 bar, higher efficiency, but doing anything like that is at your own risk, as you could very well damage the system. But typically, if you're getting overpressure on here, it's probably that the valve after the RO isn't set correctly, or you're getting that your water valves are closed and the RO just keeps building up pressure as it's not allowing the wastewater to actually release. Then pre-treatment lockout, we don't normally really use this. This is just if you have something connected up to the board inside that tells the system when the pre-treatment is busy with regeneration or a flushing or a backwash cycle, just so the unit turns off while it's busy with that. And then if we look at the normal lights down here, there's simply an indication light for each of these switches to tell you when it is running. If it's on automatic, if it's off, it should always be off. If it's on, it should always be on. Typically, as mentioned, leave everything on auto. If you have the feed pump connected, then you can leave it on auto. If you have other things running on the same feed pump, you can leave it to manual to keep it on. But we normally recommend leaving everything on auto, except if you have a high mineral content water where you might want to do the flushing of the membranes manually. But yes, that's basically the whole RO system. It's not the simplest system in the world, but it is what we feel to be the simplest complete RO setup that you can get. Thank you for watching.